All right.
All right. Don't kill it.
The song cuts off right in the middle. It needs to keep going or stop at a nice breaking point.
Ezra, you're muted, by the way.
Hello, everyone.
Hey,
There we go. We're here. Everyone's here.
Yes, it's another Wednesday, and we're here.
Another Wednesday. Another
We're
Humpday
here,
Q&A.
We are here. We're here.
We'll do brief introductions as some of our attendees will have to pop in and out. So let's
words.
get on with
Short
the show.
words.
My name's Simon Over, Flutter Community Leader, CTO at Dev Angels London. You can follow me on Twitter and other places at Dev Angels London. Randall.
I'm Randall Schwartz. I am a Flutter Google developer expert, have been for coming up on, this month, 8 years this month. Yay. So been doing that for a while, which means I answer a lot of questions for y'all on all the socials. You might have seen me in various places, but also for this show, I am the question magician, which means that I am watching the live chat. If you put Q: in front of a statement, I will take it as a question for us, the panel, and I will mark it and take them in the order they're received. Danielle?
Yeah, hey everybody, I'm Danielle Cox. I'm one of the organizers of the Flutteristas. We have Esther on here who is also, but and I'm also the Flutter tech lead at a startup called Ardley, and we live in interesting times, I guess. And sorry I've been missing, but the powers that be keep scheduling a 12:30 meeting for me every day now, so that makes it hard to be here. So I will only be here for the first 30 minutes or so today. Anyway, that's me. I'm going to call on Matt.
All right. Well, good morning from Silicon Valley. My name is Matt Carroll, known online as Super Declarative. I was once a member of the Flutter team, and since 2020, I've been a Flutter educator, consultant, and contract developer. And I'm here today to talk to all of you about render objects.
And Ezra?
Next up then is Ezra.
Hello, everyone. I'm Ezra. I'm also joining from Berlin here to the stream. I'm also lately a Google developer expert in Flutter and Dart too, and I'm also joining here to answer questions, and I'm excited about discussing render objects with Matt.
Cool.
And Randall, we'll do this briefly. Go on.
Yes, be nice, be cool. Don't post anything that's rude or adult. Don't advertise, promote anything. If you paste a URL, we won't see it. Nobody sees it. So don't try to promote your own thingies. It doesn't work. You want to promote something, get on the show. Get your face on the screen. Don't spam. Don't post the same thing again and again. We do have ban hammers in case people do something stupid, so don't do anything stupid. But do have a good time. We have a great time sharing what we know with you, and we'd like you to respond likewise. There you go.
And if you do want to post a link or some code or something else, you can share that with the I guess attendees is the best word. Panel. Yeah, that's the one. Go to gist.do, fill in some sort of type description, pop in name your file.dart to get over the syntax highlighting, paste your code, snippet, comments, whatever it is, and then grab the hash from the URL and put that in your message. If you put a link in your message, your entire message does not come through. Right, that's all the usual stuff. That's all the usual stuff.
You should definitely unblock renderobjects.com. You should allow those URLs.
Yeah, I'm afraid we don't get any URLs, and it's a YouTube thing. So
Yes, it's not us.
However, we ourselves, the people on the screen,
we can paste it.
Promote things. We can send
the people with blue on their names can paste URLs. If your name's not blue, it's gonna just go away. We won't see it.
Do you want to share the? Do you want to talk about what you've been doing, Matt, and share the site, or I can bring it up and share it?
Yeah, why don't you bring it up and then we can talk about it and look at it and see what's going on. While you're bringing it up, I will go through the motivation. I don't know how much people in the audience have experience with render objects or understand what they are, but as much as we like to say in the Flutter world that everything is a widget, it's closer to accurate to say that everything is a render object, and widgets are really just configurations. So for example, a padding widget really just tells a render padding how much padding to add. All the cool stuff in Flutter is done with render objects, and the more cool stuff you want to do, the more likely you're going to have to write one. Now, we all know that we live in the age of AI, so we're vibing all of our stuff, including render objects, but the big problem and the big question is, if you vibe a render object and it doesn't quite do what you want, what do you do then? If you don't understand enough about render objects to write them yourself, almost certainly you won't be able to fix them when AI can't do the job quite right. So to help the community learn how render objects really work, how to write them, and also, Simon, you and I have written plenty of render objects. I don't know about you, but I always forget, like, which mixins am I supposed to use? Which methods exactly am I supposed to override? What was the signature? And so this website here, renderobjects.com, offers both a foundational education for those of you that don't really know how render objects work, but it's also a quick refresh to remind yourself how they work when you come back to write the next one. So Simon, you just pulled up the guides. This is a lot of the foundational stuff. So if you want to come in here and really understand what are render objects, what are the responsibilities, how do they interact, you can look through the guides. If you want a quicker primer or a quicker refresher on a given method, there's the API section at the top. And then if you want to see a few real world possible examples, you can look at the examples. But that is at a high level the layout of the website. Simon, you can ask me any questions you have about that. There's also kind of a tooling part of the website we can get to a little bit later.
And yeah, so this is kind of cool. So you showed me this the other day, and immediately I was going through going, actually this is really cool because it gives you all those common patterns and descriptions about how and why and when to use these things, which I thought was really helpful.
And I do see a comment that mentions render slivers. I will point out currently this website is all about render boxes because most of us build render objects. That's the most common that you're going to find. I would like to add slivers to this at some point. It's just a matter of coming back, putting the time, getting those guides and API documents written.
You might end up creating a whole new website for that. It's that complicated.
Yeah, well, it'll definitely have its own section, Simon. That's for sure. Now, so that question was, okay, well, like, how do you know which one to use? What's the difference? The question, actually, do you want to bring up that question one more time so people can see the names? So render box, render sliver, render object. Render box and render sliver are actually implementations of a render object. So those aren't on an equal footing. It's like render object up here, and then you can either go render box or render sliver. If you need custom scrolling behavior, that is what render slivers are for. And that's pretty much your heuristic. If you need custom scrolling, that's a render sliver. If you're not trying to interact with the viewport, that's a render box. A render box is just a rectangle, takes up space. Render slivers do weird stuff as you go up and down in the viewport. So that is your heuristic there.
We won't go into render views. That's an entirely separate thing. But but yeah, I was just going to see if there was like the implementers, like the base implementers of render object. But there is actually more than I remembered. So you have your render box and render sliver.
Yeah, I mean, and of course we see some mixins here, which is mixins are related, but they're not really a true subclass, right? So in the big picture, render box and render sliver is pretty much all you got to worry about.
Render view is the base root of every. I'm gonna say window. It's kind of view. This is really confusing because lots of in a lot of hierarchical like widget and a lot of hierarchical kind of widget UIs, they say a view is each one of the widgets, is each one of the components. But in Flutter terms, a view is a surface that the Flutter engine renders to. So that's why you have this kind of API view.
Yeah, render view. There might be something called window, but a render view is kind of like a window in the Flutter world.
Yeah, and that's backed by the Flutter view, which is the base thing, and then render view is that base class that actually handles the root of that tree. So
that's right.
Anyway,
now, by the way, you want to look at the examples, and we can look at some reasons why you might create a custom render object.
Yeah, go for it.
So let's start with the Nest thermostat. And for those that
I wonder who
I am. I never worked directly on the thermostat, but I was at Nest for 3 years. I worked on the smoke detector and alarm system and stuff like that. But I was always a fan of the UI for the thermostat. So I created it here in Flutter. And this here is an embedded Flutter widget So Simon, if you start dragging or tapping around the dial, you should be able to change the
Oh.
temperature on that.
Whoa.
Nice.
That's
Nice.
And so this is a pretty faithful porting of the Nest thermostat UI. Now that is a bug right there when it's that off text is slightly
No.
mispositioned. That's how you know I made it. It's there's a
fix
bug.
Let's fix it.
So many of you out there might be wondering, when should I use a render object? And there are various ways to think about that. But if we consider this widget right here, just try to ask yourself how you would create this. In fact, this is probably a good question. Now, Simon, you've done so much with crazy widget trees. I'm not going to ask this of you. I'm going to ask this of Danielle and Randall and maybe Ezra. How would you build this in a widget tree without a custom render object?
Very poorly. I would not do well.
Who has slightly more details than that?
Okay.
Well, I mean,
Because it can be done. Like it's not that it can't be done.
Yeah.
So let's compare and contrast a little bit. What would a
Position.
widget tree look like for this?
I mean,
Stacking
definitely be a
positioned,
stack.
obviously.
Yeah, definitely be a stack.
Well, so what are you stacking and what are you positioning?
Well,
Circle. A
quite
custom
possible my-
paint.
yeah.
Oh, that's what we're talking
No,
about.
go ahead, Randall, go ahead.
No, I was just saying I'd use a custom paint, but that's like exactly the opposite question. I'm trying to figure out how to do it just with widgets. So
Well, no, custom paint's a widget. That's fine. So what would you custom paint and how and what else would you need?
I'd probably all the little tick lines would have to be like a loop to paint them all at various spots around the curve. And then circle and a bigger circle, and the things down at the bottom would be, so I'd have to get all these right. Actually, it could all be one big custom paint. Actually, yeah, that would be.
It can be for the appearance. Now, what do you do for the tap and drag gestures? Which, by the way, only apply radially.
You put one big gesture detector over the top of it, and you take the coordinates and figure it out yourself.
I mean, it's also a circle that we have the diameter and the degree for it. Then we can use angle or degree for swipe gesture matching.
Yeah.
Yep. So those are the primary components. You would use a custom paint in a stack beneath the gesture detector on top of it. But here's the key thing you got to realize. You effectively implement layout twice. You have to implement layout to paint it, and you have to re-implement layout to understand where the hit testing areas are, because the hit testing areas are based on what you're painting. So if you happen to change what you paint, you then have to go find your gesture detector and change what those touch boundaries are. These things can diverge. It's a maintenance issue and concern. But a render object includes layout and painting and gestures. So by putting this in one render object, you have one implementation for all of these concerns. So yeah, I guess Simon, if you want to, we can look at some of the implementation here. There's quite a bit going on, so I don't know how deep you want to get into it. But we can see the layout, the paint, and the gesture handling. Now, in the case of layout, it's actually very simple for this, because what is the one responsibility of layout? The responsibility is to report your size. So arbitrarily, we take constraints into layout and we say, we'll just be a square. We'll just be a square that fits within the constraints, and that's it. But what you see down here, there's some additional stuff happening here during layout, only because we have some text. And typically, if you have text in a render object or a widget, you want to report the text baseline. And so in this case, rather than calculate that multiple times, we just calculate it once in layout. But this is not necessary for layout. This is kind of like some extra concern that we're dealing with.
I seem to remember there being a shortcut for this, actually.
There might be. I may have taken some long ways around in some of this stuff. And so here's the paint. So by the way, Randall, this would be the same as your custom paint behavior, just inside a render object. So we'll paint the background, the ticks, the button arcs, the text at the center, and the button chevrons. And then we have our visuals.
I suppose you could also, if you wanted to, like, so the good and the bad of render objects. Let me just talk about this for a second, because this is something I've experienced with Flutter. So obviously the good is the world is your oyster, right? You can do whatever you want. You can do your rendering, you can do your paint the screen however you want, do whatever you want. This is brilliant, right? The kind of bad thing is, if you just do that, now you have to do it all yourself. You can't really, it's kind of harder to integrate with the widget system, if that kind of makes sense. So there can be that middle ground, which is making your render object a layout, is what I would call it, right? So in this case, you could actually have your text not necessarily rendered by the render object, but be a multi-render object, and then supply a slot for text to be rendered on the screen, and it positions it and gives it a constraint, and then the actual text could be rendered by a text widget, right? Does that kind of make sense?
if you want to make it configurable, that's actually a decision I purposefully went against.
It makes it more complicated.
Well, it's not just that it makes it more complicated, it's that a developer who uses that widget can do something they're not supposed to do. So like, let's say that you're actually at a company and you're actually building this thermostat to be put in the app. You don't want a developer putting random text or something in the center of the dial. You want to control it.
I suppose this is the difference, and this is another thing that we've spoken about before on the show. This is the difference between building a library and building a component for your own app, right? Build a library.
But it's a question of intention. Even when you're building a library, is it reason? Now, I would say probably in this case, in a library, it would be reasonable to let anybody put what they want at the center. But you got to ask yourself, should this widget ever allow another arbitrary widget to be added? And if the answer is yes, by all means, but you should think that through. It's not good to actually make everything configurable with widgets all the time.
Oh yeah. No, I'm saying it's the difference between, say, like having a dial widget, which is generic, versus having a thermostat widget, right? Which is a specific implementation of said dial, right? So I'm just saying that it's nice that you do this and everything else, but there is that kind of, at some point you may want to put a widget, an arbitrary widget inside of your render object, and there are ways to do that. Is what I'm saying, right? So don't think you have to render everything yourself.
Yeah, well, and we'll see that in some other examples. There's a question asked: could we create a new render polar object that uses polar coordinates instead of Cartesian?
Okay. Can I just jump into 1 second on this one, because it's actually been done by the Google team. So I wanted to show, this was going to show us. Hang on, let me can you drop the question on the screen for a second, get a bit more screen real estate back.
Sure.
I guess I'll do this. Now, so this is one of the examples, custom coordinate system, and this is going way out there, right? This is actually building a custom render object, right? This is like not just render box, this is render object. This is a level up from what we're talking about now, right? And they actually made this thing called a render sector ring, allowing you to use polar coordinates to decide like how to lay things out in a ring. I will put this in, I will link this in the chat for those that want to take a look. Cool. So this is the example, and then the actual implementation of which is in the sector layout. And this is a completely custom sector constraints, is an extension on constraints. This is going way out there, right? But this is not what we're talking about. This is like making a custom render object. And then also you can see a render sector, which extends a render object. And again, this is like kind of going a bit more out there in terms of how it brings everything together. There's a whole sort of a whole system in here, right? Again, it's all possible, and that's one of the things I really like about Flutter, right? So, sorry, I kind of maybe still use under there for a second, but I had that.
And there's no real magic in there. I mean, supporting polar coordinates just means that you are translating polar coordinates to Cartesian. The screen is always Cartesian. It's always X, Y from 0 to screen size. But yes, you can add that layer if you want, as Simon just showed. You can bring in, you can take in your data structure for a polar coordinate, and then internally you can figure out where that sits on the Cartesian canvas.
I did a custom render object which used lat long as its position for its widgets. So it's essentially a map, right? And we wanted to position a bunch of data on the map. And rather than saying, okay, give me the pixel position and like have child objects, no, it was just lat long. And then in terms of how it renders on the screen, it knows what the mapping is between the the lat long and the X,
Did you
Y
do-
was running
did
on
you
the
use a-
screen.
Did you use a parent data widget similar to a
Yep.
stack to add that to the
Yep.
children?
Yep.
Hmm.
So the idea was that you just chuck these things in there and it will choose what it can render and what it can't render, and yeah, it's quite cool.
All right, why don't we jump to the message attachment? We'll look at another example to motivate a custom render object.
Before I jump on, so you got hit testing, right? So this is so that hit test self, right? But you do there is that kind of you get the, let's say, handle event. That's what I was going to say. So like basically every render object gets this option to handle.
Yeah, and
if
let's
it
quickly
says hit
mention the
test true.
difference. Let's mention the difference between those. When people hear hit testing, they tend to think, oh, this is about gestures, and that is not true. Instead, I want you to think of it more like a video game engine. And there's this ray that's coming into the screen, this line that's pointing into the screen. And Flutter is asking, what in your widget tree hits this line that's coming into the screen? And if this line hits your content, you return true. If the line goes past your content, doesn't hit it, you return false. But this is not necessarily related to fingers or a mouse cursor or anything like that. It can be used for semantic purposes, which means like accessibility. It can be used in testing. This is a generic question of what hits this line going into the screen, which is different from, scroll a little bit down again, Simon, this other thing called handle event. This is specifically, you can see a pointer event. This is the fingers, this is the mouse, something like that. This is where render objects, if they choose, can do custom gesture handling and overriding and things like that. So yes, hit testing is relevant for gestures, but gestures are a subsection. They're completely independent of hit testing.
If I remember right, you don't get the handle event calls if you don't hit test.
That's correct. So it's a sub. You have to hit test true to handle event, but hit testing also is related to other things that have nothing to do with gestures.
And then I will say that the whole thing about how gestures work, that's a whole thing on top of this, which is like the gesture arena and which gesture wins out of another gesture. Gestures are a sequence of events, pointer events that occur, right? That's what gestures. Just throw that out there for those that don't know.
As I recall, the unpainted areas of your area are not true for hit testing. Is that true?
Well, it's your choice. And so actually, someone from the Flutter team came around to the GitHub for this website and said we should clarify about the hit testing. And I'm still waiting for him to give me what kind of the official description is. But the heuristic seems to be, if you have if the hit test corresponds with a non-invisible pixel, you should return true. Also with the consideration that even if it's an invisible pixel, if you do want to handle gestures, as Simon said, you have to return true. Because if you turn false, you won't get the gesture callback. But so those are the two things. Do you paint something there, and or do you want to handle gestures there? If yes, true. If not, false.
Now, the method of I saw just earlier was always true, so you're not paying attention to whether it's paint or not, right?
Because we're painting everything in our size.
I'm gonna say that this is actually a shortcut. There is a hit test function. Hit test self is a subcall that takes place. So hit test calls only within your bounds, and then it calls hit test self, and then you return true or false. It's kind of like there's a shortcut that takes place.
And it's also to that point, Simon, it's also important to recognize in this particular render object, we have no children. Because it's both about reporting yourself and your children. We don't have any children, and we paint everything. So we can just do this one little method here, and we're good to go.
I do want to admit, this is so cool. I've used this so many times, and you don't have to. You can do this on your own. You can use the debug paint flag anywhere in your code because it's a global flag. So you can do this inside of. Don't have to be inside render objects. You can do it inside of custom paints and all sorts. And I actually got a widget. I've actually got a package and a widget, which is like debug paint. You just wrap you can wrap part of your subtree and just turn on the debug paint flag for a subtree of your rendering UI. Are you off now, Danielle? Oh, so cool.
Yeah, if my meeting ends up ending soon enough, I'll come back.
Yeah, please do. All right, nice to see you. Yeah, so you can actually, careful consideration, you can actually turn this flag on and off for a portion of the subtree, which is what my widget does. But it's so nice to actually like be able to like add in extra UI that's only flaggable on when in development. So
Yep. And in this case, I added the debug paint. You can't see the gesture bounds, right? So with debug paint, I'm basically taking the same math for the gestures and painting those bounds to double check that what I'm painting matches what you can touch.
I should be able to write that because I'm getting 500 back.
I'm assuming she didn't mean to be here.
Yeah, that doesn't sound like us.
Yeah. Okay, sorry, carry on.
Let's see, does the hit test for clip rect or clip oval work by overriding the hit test self function? Probably. So clip a rounded rect, clip an oval. I would assume that if you touch in the part that's clipped, it reports false. And if you touch in the part that's actually displayed, it returns true. So
Should we have a look?
Hit test self, it might not be hit test self. It might just implement the actual and regular hit test method. But I would guess that there is some logic in there to do that.
Let's have a quick look. I've got the source code. Why not? Render clip. Can we go to the definition? Yeah.
You need a real checkout with a real IDE.
Yeah, I just want to quickly do it in the browser, but nah, I can't be bothered with that. Unless we can quickly find the.
Just press dot. It'll bring up a VS Code in the web browser.
It didn't do it for me, so.
What? You didn't pay your Microsoft tax.
Yeah. Anyway, there we go. Hit test. It passes it over to the clipper, which has a contains function. So the actual implementation goes back to the delegate. So the way that clip rect and clip rect work is that they work with a delegate. Let me just briefly bring this up because it should take 2 seconds, and then we'll get back to
which is just it's effectively a shape. So it's going to ask the oval if it contains the point. It's going to ask the rounded rectangle if it contains the point.
Yeah, clipper. Yes. In short, yes. I'm not going to find what I'm looking for right now. It doesn't matter. Anyway, you go hunting. But yeah, you can go searching through the source code yourselves, right? So to answer a question like that, you can always look at the source code. Flutter is open source, right? So okay. I think that's semantic. Yeah, debug properties, lovely. There's lots of things. Should we go message attachment? You wanted to talk about this, didn't you?
Yeah.
Sorry.
So I'll give you the motivation for this one. And this one's kind of minor, but it's something to keep in mind. So let's say that we're creating a little chat editor and we want to add attachments at the top of the chat editor, like all the AI stuff does. And it's going to have a thumbnail and then it's going to have the X button to remove it. Notice that in this particular version, there's not like a border around the X button. It actually cuts out a hole in the top right of the thumbnail. Now, Simon, I see you smirking. What's this smirk about?
Oh no, because I've had the same thing. I've done the same thing. It's all right. It's like it's one of those pain things when you're like, you need to remove something from the UX, and it's like it's not as simple as all that when you've got like widgets and layers and so on. So yeah, you end up doing custom render object. Yeah,
well, so let's start now. This is just like the others. This can be done with a widget tree. So why don't we start there again? You guys tell me without looking at the code. Don't go look at the code. Just stick with the UI here. What approach do you take to the widget tree if you need to create this with just widgets?
Stack, obviously. Position the profile picture. Put a purple circle to cover up the corner, and then put the little black.
Nope, can't do that. Circle. You need to, because if there's a gradient behind it or the background changes, you got to see the actual background.
It's harder then.
So you can use a custom clip clip a shape
Custom clipper. Yes.
on the image, but that means that you have a problem now in terms of that the X, you always clip into that circle, for example, or a radius of circle. You can't like have the one widget dictate a random shape for the other one to do it. It becomes a bit more complicated when you start going down that route. There's also trying to remember what the name of which is shader mask that can also work in a situation like this as well. Depends on obviously if you're trying to do things like a fade shade, like a fade cutout and other fancy things, you can end up doing some shader mask for that kind of stuff. But yeah, simple.
So if I were to do this, I'd probably use the custom clipper that you mentioned. Sorry, Randall, go ahead.
Or take the image and change its alpha in the corner.
I mean,
so you would just
manipulate
the
with the worst way.
It's a way. It's a very slow way. I wouldn't want to do that.
Right, but you're
so
just looking for ways.
I would use the custom clipper approach, and it's fine. That might even be the least bad option. But the thing about the custom clipper, like let's just pretend that it's always going to be a circle, so you don't have to worry about some weird shape. But from a maintainability standpoint, what you're going to have is like up here in your widget tree is the circle with the X, and then way down here at the bottom of your file somewhere is this custom clipper, which is responsible for understanding that it needs to cut a circle based on the size of the circle up here, so that you have this gap in between. And here again, you have a maintenance issue. If you change the circle, make the circle smaller or bigger, you better remember to come way down here to the custom clipper and do the same thing. Whereas if you create a custom render object, the same place you paint the circle is the place that you cut the hole around the circle. So it's in the same area of the code, and you don't have drifting maintenance concerns. That can be a reason to use a custom render object for something even like this.
There are ways to do it the other way in the widget tree, depending on what you're doing. If you do need to have that separation between the two things, and that is to do like these use inherited widget and things like that, to actually have the two widgets communicate with each other about how big it is, and then that tells the other widget how it should cut out. It's not ideal though, and it is that you get you can potentially get, depending on how your layout is working, you may get like an extra frame where you can't render because you need to pass there before and then pass that from one widget to the other and then have it cut out in the next frame. So yeah, but there are mechanisms to that. But ideally, yeah, if you're just going to do a widget like this would be one widget, right? One render object.
Yeah. And the interesting thing about this one versus the last one is that this one does have a child. So that thumbnail needs to be a widget of some kind. Like we're not going to enforce that it's a URL image or a local image. You can have any widget you want. And that means that we're actually we're clipping the corners of a widget, and we're punching a hole in one of the corners of a widget. And that is a little bit interesting in the paint method, because for those who have implemented any paint methods, this one then uses Flutter's layer system to be able to actually clip an entire subtree. Yeah, so there's the line. The important line right there is that layer.
So this is like the standard clip widget with a custom clipper effectively does this, right? That's effectively what it does at the end of once it processes its piece. But again, the difference being that now what you've done is you've separated the concerns of clipping and rendering, and that can become problematic. You can also do an interesting thing depending on what you're doing, which is again maybe slightly less optimized, but you can do you can use a save layer in a canvas. If you're trying to do like it all in one paint rather than like a child widget, then you can actually do canvas save layer, and then you can render clear as a color. There's a way of actually like removing data from a save layer inside the canvas, and then you restore, and essentially what you've done is you cut out that section of the canvas that was previously painted.
Yeah, the important point here being that you cannot use canvas clipping with a child widget. So that's so yes, you can do some interesting things with the canvas. The reason we have a layer here is precisely because we have a child widget inside of us, and that requires an engine layer.
And I did notice that it was very subtle up here, but I wanted to explain. So there's obviously there's a distance here that you're cutting out, and that distance is also around the edge, which is obviously not. It's hard to see here, but there's a distance. That same distance is from the edge of this X to the edge of the child. And then what we've got in here is that deflate going on to remove that edge, and then we're using box parent data, which is how widgets are positioned in render boxes. They're positioned within their children, within their parents. Supplying the offset of that to be X and Y, that value, so that pushes it in here.
Yeah, I mean the name of that thing's a little confusing. You can just think of it as padding. There's a little bit of padding around the thumbnail image, because like if you go back up to the UI there for a second, the question that you have to ask is, what do you want the layout bounds of this to be? Do you actually want, like on the left side of this widget, is the layout directly on the left side of the thumbnail? Or do you push it a little bit to the left so that you have symmetrical space on both sides? I chose to make it symmetric because that circle button sticks out. There's a little bit, I added a little bit of padding all around the thumbnail, and that is our actual bounds.
I'm also going to suggest to say something else. What you can, if this was the child bounds, let's say the actual image, you can position another widget like negative outside, and it will render. However, the hit testing will, by default, will not work. So hit testing only works within the bounds of the parent by default. So you can get yourself into a situation when you're testing, you tap here and it works, but when you tap up here, it doesn't work. So that's one of the reasons, again, but you want to make sure that
Interestingly, though, every child of a parent will have an opportunity to hit test. So when the hit test hits your parent, no matter where, like the parent does not filter the children. The parent does not say, well, is my child here? Is my child here? The parent goes to all of its children, wherever they happen to be, and they say, we're going to run hit test on you. So as long as your parent is large enough, you can actually put things outside your layout bounds and still report true on a hit test, but that will likely get you into weird situations that you don't expect, and then you don't know why your widgets or render objects don't seem to hit test in the right place.
There is the default implementation for multi-child render object is to it's like one of the mix-ins or something. It literally like does influence hit test children, and will default to just the bounds of the parent it has to be within. So there's like an optimization they've done there. Anyway, but you can obviously override it, right? If you're doing your own render object, do well choice to do it. Intrinsic sizing is another interesting thing, I guess. So there's this notion that you might have one axis because I'm trying to think of a good example of this. Things like a row or column where one axis is undefined and the other axis is defined, right? So you might have the width of a column, but not the height, because the height should expand to match whatever the content is. Then you'll get a compute max intrinsic height in that case, because it's a column with the width of the column, right? As the constraint coming in, and then you're expected to output, here's how high my child should be. They don't particularly use intrinsic height, but I'm just using that as an example.
And everyone who creates a custom render object, if it's possible to have a reasonable intrinsic size, you should, because if you're placed inside of scrollables of various types, your widget will throw layout errors if you don't have an intrinsic size. So to maximize where your widget can be used, you should report some reasonable intrinsic size if you can.
A lot of people don't know about path.combine. I'm surprised by that. Every time I talk to people, like they don't know that you can do these really cool path operations.
That was probably AI generated anyway. I don't even know if I remembered that thing existed.
Well, anyway, so on that point, maybe I'll just like bring this up. The path, funny enough, so a path, we talk about paths. Path in the rendering term is think of it as a shape, a border almost, right? It's actually a series of instructions to where to move like an invisible cursor, shall we say, like a pair of scissors, like cutting out a shape. But it's the path it follows. That's the term, right? But when you do a path, you get to add in, as you can see over here, add arcs, ovals, rectangles, and this allows you to move that cursor and cut out and essentially whatever shape you want. And this is not meant for clipping. This is just recording that path, that shape. And then with Canvas, you can say draw path and say, okay, paint this path to follow with whatever shape I want. That could be like a border, stroke, fill, image, you name it. There's all sorts of funky things you can do. Well, path.combine is one of these magical things, which basically is a really complex thing to do. If you try and do this mathematically yourself, working with polygons is not for the faint of heart, especially when you start going to convex polygons. However, yes, you can do like difference, intersection, union. These are all like kind of standard operations. You'll see these in things like Inkscape and other vector editors and things like that. So if you want to try them out, but basically allowing you to say, okay, there's actually images. I'm not sure why they're not popping up in here. That's really interesting. There were some images of the path operations. I don't know where they are in the documentation anymore. But basically, you have like a square and a circle, and you show you how they overlap and what cuts out what. So union is an OR, essentially inclusive OR of the two shapes, and so on. XOR or reverse difference intersection. So anyway, so the cutout operation that you were just performing in there is actually that. So we're saying add the rounded rectangle, that's the entire outside shape, and then difference that with the oval that's been created from the circle rectangle, and that means
which
that
means means we're cutting the circle out of the rounded rectangle.
Yeah. Allowing you to create a new path, which instead of being around a rectangle now has that curve at the top edge. Very cool.
And Ren, do you want us to cycle through the pending questions?
I tell you what I would. Sorry, just before we jump out of this, looking at this, I tell you what I would be doing if slightly different in this, and that is I would be storing this path inside of my render object, and then that shape is what then I push through to things like hit testing, so that you're not recalculating it and so on. But
yep, that would work.
There was a quick comment about making sure you dispose the text painter object. So make sure that you do that.
Do we not dispose it?
I think it is. It just may not be in the pieces of code that I pasted in there.
Yeah.
It's created during, or it's created or updated during. Actually, maybe it's so. No, we're creating it locally.
Yeah. So maybe
I mean, probably should dispose it. I'm guessing that it falls out of scope and will likely be garbage collected anyway. But yes, technically you should dispose it.
We used to be a lot more problematic. I remember the early days of Flutter where we didn't have finalizer in Dart, and that was actually a bigger problem than it is now. A lot of the cases now, the finalizer, the Dart finalizer has been hooked up to a lot of the native component, a lot of the classes that are backed by native code, especially that's a lot of the rendering stuff inside of the Flutter engine, and a lot of them just they automatically free the native code and they'll dispose of themselves if they're not registered in Dart anymore. So.
And Ezra has one little comment here. Why should you just come on screen and ask it?
There she is. Yeah.
Oh, there. Ask him.
My question is, how much does the move toward impeller change? Like right now, we are also hearing so many updates from Flutter team and community as well. How do you think about custom painting and performance?
It shouldn't make any difference unless the Flutter team screws up, because this API is on top of the engine. So the entire concept behind moving from Skia to impeller is everything at the Dart layer stays the same, and we're just switching out how we implement graphics under the hood. And really, if anything, again, if impeller really is doing what they said it was made to do, performance should improve in general. because supposedly Impeller is this rather Flutter-specific, app-specific graphics system, which is meant to pull out a lot of the unnecessary, maybe overly complicated parts of Skia. Though I will give a shout out to Jesse Ezel, who you can go find on X, who's been working on, it's hard to even describe what he's doing, but he's basically reworking Flutter so that it brings back Skia and Graphite, which is a new part of Skia, which is meant to solve the problems that Impeller solves. He's also bringing in WASM support. And so you might be interested to see all the really cool stuff he's able to render and build with his fork of Flutter. So we'll see Jesse's effort versus Impeller, which one ends up being more exciting for the community. We'll see.
Joe, it's funny. What you just mentioned there is that the Skia team, which is also Google and open source, but and then you got the Impeller team, are both basically done the same thing.
Jesse has been harping on this for years. He's been saying, like, what are you doing? You're both at the same company. You're solving this, like, and specifically Graphite. So Graphite is this thing that Skia created. And in principle, in statement, the reason they built it was to solve the same thing that caused the Flutter team to try to stop using Skia and create Impeller. And Jesse's been saying, why are you doing these two different efforts? Make it one thing. And Jesse's point is also that the Skia team is huge, well-funded. Skia is used in Android internally. Go with the major infrastructure.
It's kind of interesting. It's one of those things, right? I think what's probably happened here, right? I'm just guessing, right? But I think, I think Graphite came along after the Impeller stuff, right? They were asking for it. They probably said no. Then we had Android Compose come along, and then Android Compose now dictates more of a pressure on the Skia team to move to more of this custom rendering approach app side. And I suspect that then the Skia team can start coming up with Graphite because they need to solve their problem rather than because Impeller was very specific to probably more specific to Flutter's use case, right?
Yeah, that's a fair point, which is, I don't know the exact cause and effect, but you are correct in saying that the Flutter team started Impeller before Graphite was anything that could be reasonably shipped with Flutter. The question then becomes, should the team have treated Impeller as a temporary stopgap until Graphite became usable, or should Flutter have gone all in on Impeller and, like I was saying, we're not looking back, we're not considering using Graphite? That becomes the big question in the long run.
I remember the time when Impeller was being talked about. There's other considerations taking place because of some of what Skia was bringing in, and because Skia's surface is huge, it's got a huge API surface. I think there was a notion of trying to bring that back.
Well, that's also one of the really cool things about what Jesse is doing is that because on the one hand, it's huge and you don't need all that. We want to cut it down. But the other side is, Simon, you and I have been here 1,000 times. Flutter does not give us access to most of the text related layout stuff. So if you want access to individual, like, remember when Apple came out with the ability to animate each glyph and everyone was like, oh my God, this is amazing. We couldn't do that in Flutter because Flutter doesn't tell us about individual glyphs. We literally, API is not exposed to us. And so what Jesse has done is create the opportunity to get as many Skia APIs as you want in your app, which should include all of those text layout behaviors as well. So that's, yes, Skia does a million things, but sometimes you need some of those things that Flutter cut out.
Got a couple more questions real quick here. If you want to take,
you have it to do, by the way, to link the repo at the bottom of the web page.
Yeah, and this site is a work in progress, folks. In fact, before we get to the next question, Simon, go to one of the guides real quick. Just pick any guide.
Yeah, hit testing. Yeah.
Select part of the paragraph of text there. Just select some text. You see that report mistake? That's going to go to GitHub, where you can open an issue and you can say, Matt, this is wrong. Here's the right answer. Fix it.
Wow.
Do you know it'd be even better if you hook that up to like a GitHub Copilot thing where it's just like put it in, then it submits, and it automatically generates like a PR and
just fix this.
Yes. See, if AI knew what the right answer was, this would be the right answer. Right. So I want the human information. You tell me what's wrong and I'll get it fixed.
Yep.
Did I see also AI stuff on here? Was there like LLMs.text, or am I thinking about something else?
Sorry, what are
I
you
feel like
asking?
there's I'm feeling, does the website also have like LLMs.text and Claude.md or something like that to give
I don't think so.
to is that something else that can also be helpful, right? To teach the AI, here's all the render object information you need. So when I'm working render objects, this is the source of truth that you should use, right?
Yeah, it could be good. If one of you knows how to correctly expose that, feel free to put up a PR.
Is this site done in Jasper?
It is. It's vibe coded, so I couldn't tell you how any of the Jasper code in here works, but I figured if I'm going to
Mine
pick
either.
one of
Mine
these
either.
toolkits, might as well do it.
I just told Gemini I want a Jasper website that has the plugin for documentation, and it just made it.
Yep.
That's easy.
And Victor, you are welcome for the educational material. I hope you'll help find mistakes and blind spots. And this is a work in progress. This is a start, not an end. Let's keep it going. Let's get the community all learning about all the custom render objects, making cool stuff.
And a couple quick questions still left over here. Can we cover the mix-ins?
So for
when do you use
for mix-ins, Simon, go up to the click render kit at the top right.
Oh yeah, this is cool. Let's go to this now. This is cool.
Let's generate a render object. This is going to be related to the mixing question. So just pick some kind of render object you might want to build. Just because we'll answer a series of questions, but let's pick something you want to build.
Is it a chat?
If any one of you has any idea. What was that?
Let's see. Is it an AI chat? Or are we actually chatting to Gemini?
Yeah.
Well, it's not. It's a chat. It's not AI. It's actually there's a hard coded set of possible outcomes. But
it's really cool though. I have to say this is brilliant. Let's just call it. I don't know, like
Humpday.
Movement dial.
Sure. Okay.
How am I?
And then it's going to recommend the name for your render object.
Yes, thank you very much.
Render movement.
How many children will this render object have? We'll have one. Do you need custom paint and compositing?
Nice, interesting. Both.
What is the desired hit test of behavior? Partially hittable. Yep, sure. Will your render object publish semantic information? Yes. Will your object recognize the handle and gesture internally? Yes. Does the render object always require specified constraints, or does it have intrinsic size?
I think
so. It has intrinsic size. Does your render object need to run during like that builder? I don't know. Let's make a difference. Perfect. I have everything you need. I don't know, generate your skeleton. And there you go.
All right. So we can look at this a little deeper, but to connect this back to the mix-in question, I have no idea what the mix-ins are called. I never remember. The names are ridiculous. Here, but by generating it, there's your mix-in. That's the one that you need for this. So if you start here, you don't ever have to remember that. In theory. Now, by the way, because there are all these different questions bring different pieces of code into this generated skeleton. It's very possible that some combinations aren't quite right. So here again, if you run into something missing or it's not giving you the right pieces, let me know. But I have used this to create a number of custom render objects.
Yeah, I had to play around with this when you sent it over to me. I was like, actually, this is like super helpful, right? Just to be able to like just generate a skeleton, and these are just normal set of questions, right? Let's do slotted. Yeah, sure.
Seems like it would be useful as an LLM skill as well.
Yes.
Can you tell an LLM which questions to ask you, though?
Yeah.
Yes.
Okay.
You can give it a script. So it's how the chat agents work on a lot of websites. You can also do like it's like a system prompt. You can also do a nice little thing where it outputs it as like JSON, and then your code can interpret that.
Can we? Is there a reasonable way to get a decent LLM for this on the website, or is it something you would just load the skill locally and have to use your local LLM?
Do you know what? I would be my thing about putting LLMs like that on a website. I would put it this way. My problem here is that you wouldn't want to go straight to the LLM APIs from your website with an API key that anyone can use and put.
Yeah, I don't want to pay it. It can't be paid. It needs to be free.
So that's when it kind of falls down. So what you've got right now is perfect for this use case, right? And when I saw this and I thought it was an LLM, I was like, that's gonna run up a bill. So yeah, I think it's fine how it is. But you could offer it as a skill that someone can put in their own, like a system prompt that they can put in their own LLM, and then it will ask the right questions, and it's on their bill on their dime.
So one of the benefits here, though, actually, I think maybe is that it's not an LLM in the sense that while you can answer questions in different ways, the output is essentially static.
Yeah,
that there's only a set combination. We can look up what that combination is. It never changes.
So here's another example: multi-child render objects. You have your create update, and you get these lovely mix-ins, container range objects. There are other ones I want to say. There's default mix-ins that you can implement that are, I scrolled across. No, they're not there. Yeah. Oh no, the defaults. There's a defaults one here. Yeah. There's a few of these that go around which basically implement what the render object system kind of needs by default. So that is like passing on to looping over the children, setting out the hit test to the children, and so on and so forth. So that's what the defaults provide. So anyway, let's see. Perform layout. Yeah, goes for each child. Lays them out. Hit test. There's that default saying about hit testing. Yeah. There's also one for paint as well. There's a default paint.
I think the reason that that's an unimplemented error is because you said you wanted to do custom paint.
Yeah.
I think you said that.
I think I did. I don't remember. But yeah.
I bet you could point Gemini at the code that builds this part of the website and tell it to make a skill out of that, and I bet it could do it.
You should get LLM to update the splash screen, Matt, because that should really change its size.
I don't know what's the problem that you're seeing.
Oh well, so like if you go to a website and you've got a restrictive view, like you kind of want the certain information you want above the fold, right? And at the moment, there's no sort of mobile tablet or anything else in terms of like this layout, right? I'm just saying.
There should be should be various changes happening as you reduce the size of the window.
The logo always remains the same size, right?
I think that's okay. That's fine. When you come there on a phone, you get a big beautiful logo, and then you can go where you want after that.
It's an art call. It's fine.
Yeah.
All right, Randall. Do we have any more questions that were queued up? And after that, Simon, we can check out that Apple Watch version if you want.
Okay.
Okay. We did this. Here, this one. If someone wants to get good at this layer, what's the learning path? Well, Ezra just asked these questions directly, but she's gone.
Well, the learning path is renderobjects.com. That's where you start. As far as what you build, I mean, that's the tough part. You can build a bunch of artificial stuff to learn that can feel kind of pointless. On the other hand, it's rare that you run into something that truly requires a custom render object. So I don't know that I have great advice there. Simon, what would you recommend?
I was actually thinking so one of the things I used to do was to go onto the design websites where designers throw up their like little app and widget designs and things. And there's something cool some little cool widget thing that takes place. I'm like, okay, how do I build that? And like, I remember one which was like a rubber band slider. So you pull the slider, it's like a rubber band. And it's like the type of thing that, you need a custom render object for that. So, build a custom render object. I think there's like it's nice to go on these websites, find something, and then say, okay, I'm going to just, it's my little self-tuition to say, how do I build that and aim to build that with custom render objects. Learn by doing and also learn by failing. Know that it's okay to fail, right? That you can say, I don't know how to do that. I'm going to learn to do that, and spend the time understanding what you're missing, and go for something simple and come back to it later, once you know more. So
yeah, and it takes muscle memory, because it, like, really the reason that all of us can write stateful widgets so easy is because we've written so many of them. And init state, dispose, did update widget, did change dependencies, rebuild, the build method, creating gesture callbacks in the stateful widget, all of that stuff we've just done it a million times, so we know all of what it is. Most people have never written a custom render object, and those of us that have, we've written like half a dozen in our career. So you need some muscle memory.
And one thing I'd recommend, just as a minor thing, but it really helped once I got past that, is learn the full protocols of things like rectangle and point and offset and things like that. Because if you learn the full protocol, you'll never have to type sine or cosine again in your life. Because all of those calculations to go near something but a certain angle away, there's already method calls for all that with sine and cosine buried inside them. So you never have to remember, oh, this is the cosine of the angle divided by pi. No, you don't have to worry about that. There are protocols for everything like that.
It's definitely worth experimenting with. If you feel like render objects are too much, start with custom paint. Start with something where you do a canvas, you're calling those draw APIs, you're working with rectangles and points and whatever you want to render. But again, like, custom paint is just a paint portion, right? Now you go, I want to do input, I want to move widgets around. There's actually an interesting widget that is underutilized in Flutter called Flow, which enables you to reposition widgets, and they're just repainted. They don't get relaid out. And there's other things to optimize it. There's various other widgets. And the whole idea is that there's the whole idea of the widget hierarchy, the sort of widget system is you're trying to present something to the user on the screen, right? And like, it's broken down into a certain way of doing that. Now there's different combinations of doing all these things to achieve your result. And that's what you need to learn, those combinations of what you need to do to get the desired result. And that comes with practice.
We got one more question, but it might be a rabbit hole. So let's see. Can we look at the new package called HIT? It solves a long-standing issue in Flutter.
I think it just extends hit test bounds beyond what's painted or what's laid out.
Okay. Which is what I was talking about. I think that was the issue I was talking about, right?
Yeah. Right.
Yeah, and I don't know that it's even conceivable that a package could change that. That's very deep in the framework. This is probably just some escape hatch under some situations.
It looks like it's an interesting escape hatch, should we say, on here.
And one other sort of a tangential question. Do you have any advice on what Flutter packages you recommend for 3D? FL GPUs and early stages, 3GS, Flame.
So I don't have any particular advice. Render objects, I know they're called render objects, but they're really just about 2D stuff and working with Flutter's APIs. But there is a package called Scene, which is meant to show off the capabilities of Impeller in a 3D world. That seems to be the most significant 3D rendering package available today. But also, I mentioned Jesse's work, because Jesse is creating a fork that consumes WASM. You can use, he has a demo up of actually 3JS running in his Flutter fork, and it's just actually 3JS. It's not like a Dart quasi imitation. It's the real thing, as far as I know.
So the Scene stuff looks great.
For those that don't know, there is a Flutter GPU package now. It's if you're using Impeller, you have access to this, and it gives you a bunch of constructs for working with GPU directly to do rendering. And what Flutter Scene does, and both have been written by Brandon, who worked for the Flutter team on this, and the Scene package, the Flutter Scene package here, is a layer on top of that, which brings together essentially all the things you need to actually use that rendering system to actually build stuff, right? So it says here, look, rendering, physics, audio tooling, and full asset pipeline. So it's not as, to load this, you need something to load the data, you need something to parse that data, you need something to so on and so forth. So yeah, there's also an object system for so you can build games and things. So, and hit testing of three-dimensional hit testing. So there's a bunch of stuff in here which you can use. And he's actually incrementing quite quick on this at the moment. This is pretty cool. I have to check out Jesse's stuff. I haven't tried it firsthand yet.
Someday we won't.
I think
Blender
to use Scene and to use Flutter GPU, you need to be on the main Flutter branch. So I think you need to be on the leading edge.
No, it's unstable.
Well, so at FlutterCon, was it Brandon?
So yeah,
that was
so right now you can use this on stable,
he,
but you can't use the latest stuff he's done yet because it's on master.
Because when he spoke at FlutterCon, whatever he was showing us, he was clear that you needed to be on the main Flutter branch.
He's showing stuff he's literally done last month.
I think he did some of it the night before the presentation.
Yeah, I mean, have we all?
Yeah.
Flutter GPU is definitely unstable. And you can use it, but the most recent changes he's been making are only the last couple of months. They're not stable yet.
Does Flutter GPU allow us? Does it bring back support for dynamic shader compilation and loading, like at runtime? Because that's what we lost with Impeller. Impeller, by switching from Skia, Impeller does not allow for runtime compilation and loading of shaders.
You do, yeah. Because you literally has to compile
there's
function.
Jesse.
Doesn't it?
Jesse says no.
What's the compile function I've been using then? Oh no. It loads a pre-compiled one, right? Jesse should come on the show.
Yeah.
Yes. I don't know, Jesse. I don't know where you are right now, but if you want to jump on, feel free.
I can send you a link, Jesse. If you want to jump on, let me know. I'll send you a link.
And then Simon,
Just
do you want to take a quick look through the Apple App Grid before we hear all about Jesse's adventures?
Yeah, give me 1 sec.
He's got to cut and paste. He's got to be cutting and pasting here first. Having people magically appear on the show midway through the show is something we do frequently, apparently.
I must have said his name 3 times.
Jesse, check your Twitter DMs. Yeah, so let's bring this up.
So the one thing, so obviously anyone can go to this website and look at this, but what I want to call out about this example of a custom render object is that not only does it have multiple children, it supports effectively an infinite number of children, because you never know. This represents the app icon, the app selector on the Apple Watch. Who knows how many apps you have? Could be 10, could be 50, could be 1,000. And so this thing lazily builds only the app icons that are visible and allows you to have any number of app icons that you want. And so this doesn't just require a custom render object, it also uses a custom element. And this is where things kind of get complicated from a knowing how all these things relate together. That's why it's annoying. And this is what I say about render objects. Every individual responsibility is simple and clear. It's when the 1,000 responsibilities overlap like this, and you have to know cause and effect, this is when it becomes overwhelming and it's hard to know what you're supposed to do, which is, again, something this website is meant to help educate you out of. Elements become responsible for running build on each of those children, but the children that you build depend on the render object's layout, right? Like which ones are visible, we don't know until we run layout. And then we call out to the element and say, okay, during layout, go build each of these app icon subtrees. And then those get added as children during layout. And then when you get to paint, you can paint those children. And I know to anyone who hasn't done this, that like, I don't even know what those words mean. That is what this website is here to help you with. You have an example, you have guides, you have API docs, so go give it a try.
I did a whole talk about how to do these dynamic elements and render objects at FlutterCon Europe with
I seem to remember you speed running
with
that.
Kevin Moore.
That was,
with Kevin.
yeah,
Me and Kevin Moore was speed running that. It was fun. Like we did 2 days, and we did like the first one. We just kind of I did it on my own. Then Kevin came in. He did a here's how to simply explain this, which Simon explained really complicated 5 minutes ago. Anyway, oh, Jesse's here. Here we go.
Hey, Jesse.
Hey, Jesse. So Jesse, I've been talking up your work, letting people know that we have a bit of a war happening between the impeller version of Flutter and Jesse's version of Flutter, and which one's going to win, which one can do more, and it's all unfolding in front of us.
Yeah, I mean, definitely different goals for what I'm doing and what they're doing. So, there'll probably be a place for both always.
Do you want to just give a bit of background, Jesse? Just so people
Yeah,
know who you are.
so I've been working on a kind of different version of Flutter, and I think everyone that knows me knows for years I've been kind of frustrated with the things I want to do with Flutter that Flutter can't do. And way back when Matt and I had started Flock to try to address some of these issues, but I think with Flock, maybe one of the mistakes we made was that we thought, well, if we fork Flutter, we should keep it 100% compatible, and we should try to kind of make sure that everything's in Flutter always works in Flock. And I think maybe that just wasn't that interesting, because some of my biggest problems with Flutter they're like minor problems. They're like, you need to throw out the whole engine and replace it. And at the time when we did Flock, we didn't have LM assistance and a lot of things we have now that can allow you to make much more substantial changes. So I took a step back and said, well, what if all these things I've been saying for years are the way Flutter should work? What if I actually just did them? So what I did is I took Flutter, and I've been saying for years, I despite Flutter Web maybe being the least popular of all the Flutter variants, I've always thought that the Flutter Web engine was the best of all the engines. And the reason I've always thought that the Flutter engine is the best is, one, it uses Skia, which I'm a big fan of, and two, it's all Dart. So that actually makes it very different from the rest of the engines, where if you want to contribute to, say, the engine on iOS, you really have to contribute non-Dart code. And so that can make it really hard as an individual wanting to contribute to the engine. You have to know all these things that have nothing to do with the language you're using every single day. So the web engine was kind of interesting, because when they did the web engine, they took something called Canvas Kit, and Canvas Kit was already a thing that used Skia, and then they just made a Dart wrapper around it that implemented the engine. And so for years I've been saying, well, I was running the Flutter team, I would just take the Canvas Kit engine, I would make it support Skia Graphite, which is this kind of newer version of Skia that solves a lot of the same problems Impeller's trying to solve. And I would just make that the engine. And I wouldn't have a different, a Skia variant on Android and an Impeller variant on Android, and then two different engines on web. There's so many different versions of the engine that the team has to maintain, that they sink a lot of their time into basically duplicating effort across all of these different code bases that do the same thing. And so it started as just an experiment. Well, what would happen if I just took Canvas Kit and I put Graphite in? Would it even work? Yeah, I mean, in theory it should, right? But no one had ever tried it before. And so I took the web engine and I put graphite in it, and I ran it on web. Worked great. And so then I said, well, what if now I took that same engine and I ran it on mobile and desktop and all these other places? And what do you know, it worked great there too. And so I have my own set of needs that kind of involve a lot of kind of dynamic code gen and the ability to load code on the fly, which is like another thing you've never been able to do with Flutter. And so I combined that with WASM. You know, a couple, I don't know, weeks ago, months ago, the Dart shipped the new standalone WASM flag. And so now you can use Dart to compile much more standalone bundles of apps than you could before. And so I took that and basically took the Flutter embedder and made a new Flutter embedder that instead of running native code, runs WASM apps. And instead of the Flutter embedder on native gives you like a WebGL context, which is like super, super old. And so what I did is instead of giving you a WebGL context, I give you a Web GPU context. And the cool thing about Web GPU, you know, like I think Flutter people, we talk a lot about Skia, but there's this other like really cool thing that Google built called Dawn, which is the foundation of Web GPU. And so that's kind of the equivalent of say like Flutter GPU, but much more sophisticated. And so I took Dawn, and on native platforms, Dawn can provide Web GPU access. So like if you're on mobile or desktop. And so now I have an embedder where, you know, using the same basic architecture, I can run WASM apps with full access to GPU across mobile, desktop, and web. And it's the same exact WASM binary. So you don't have to like recompile the app a bunch of times, which I know for some people is always kind of annoying, because it's like Flutter is great and cross-platform, but then you start like installing all these plugins that do FFI, and it can often get like hard to maintain all of those dependencies across all the platforms. So,
Simon, what do you think about pulling up Jesse's X profile and looking at some of the examples he's posted of what he's talking about?
I was already doing that.
Okay. Because I know for most people, these are lots of big words and relationships that may or may not mean something, but examples of it can be helpful.
Yeah, so this is an example of like a lot of these examples, what I try to do is do things that like you can't actually do in Flutter. And so the interesting thing about this example is, well, there's a few things. One, the 3D text here is, in order to, let's say, create 3D text, you need the glyph outlines. Now, I've complained for years about how you can't get glyph outlines because
all three of us,
yeah, like I mean, like
many times.
I've worked on things that I need glyph outlines on like every single platform. Like almost anything I've ever done, I've needed glyph outlines. And the only platform I've ever used that I can't get them is Flutter. So the interesting thing here is, in order to even do this, you need the glyph outlines. Well, Skia gives you the glyph outlines. Obviously, Flutter has the glyph outlines. It just doesn't expose the API so that you can get them. And so because in my engine, it just uses Skia under the covers. It uses Skia Dart. And so you have like the full Skia API. And so to get the glyph outlines, it just calls the normal Skia outline API to get the glyph outlines. And then in this case, I have a port of 3JS that also can run in the renderer. And so it uses 3JS to extrude them, put a texture on them. And then in the background here, you see a video texture. Now, this is one of the things I've complained for years about in Flutter 2 is despite the fact that like Flutter was designed to work on phones, and like for a lot of people, they're basically just cameras. Flutter has terrible media APIs. You can't do stuff like this with Flutter. So like, especially if you go onto web, like you can't really even use the video as a texture because web doesn't even have, on native, you have texture registry. So, but on web, you don't. And not only that, there's no video primitives, period, in the platform. And so the video player itself is like this mess of FFI.
Even with the video plugin that we have, video player, sorry, say that's a plugin that we have, we still don't have an official audio one, which I always thought was like crazy.
Yeah, so that's the interesting thing about the embedder is like, what I want to do is make it more like the browser, where rather than saying, well, okay, it can only be 200 kilobytes, so we basically can't do anything. The embedder itself has a lot of services like media services and audio services that are native. And then they're exposed so that the Flutter app can use them. And so things like video are exposed as a system service. It can give you a texture that's already kind of bound to the video that you can just use in your app. Or when it comes to audio, audio is actually provided by the embedder. So you don't get into the situation where like anyone who's trying to do audio with Flutter, it's like there's a million packages and they all suck. And they all suck because it's not handled natively by Flutter, which is where it needs to be. And so you get all these people that are kind of trying to hack around this problem by using FFI. And like sometimes maybe the guy is like really good at iOS. So the package is amazing on iOS, but then it doesn't even support web, or it sucks on web. And so you get like clicking like over and over and over. And so if you kind of throw out the whole way that Flutter works and you kind of solve some of these things from first principle and say, like actually media needs to be natively supported as a first class thing by the underlying platform, then it becomes a lot more trivial to make packages that can do interesting things.
I do totally agree with that. Like it's always been something that I think the Flutter engine's missed, which is good media support. Not to say it's simple or easy to do. I think there's also a difference now that to pose that, just say 3 years ago, to pose the question of doing that would have been a different proposition to what it is today, as we're saying with like the AI stuff and what you're doing. So, we'll see what happens. I did notice that, do you mean 200 kilobytes here? I think that was...
No, like...
Because the difference in size.
Yeah, you're right. Yeah,
is megabytes, right? Like
0.2 MB.
Yeah. Okay. I was like, hang on, it's more than that. It's definitely more than that.
Yeah,
That's 200 bytes.
Yeah, I think I think we can definitely even. I think it can be a much smaller than SKWASM even in this case, but like the size right now is pretty comparable for. The WASM you get for graphite as SKWASM. Like the thing is that like with SKWASM, what they did is they tried to like trim out all the Skia stuff like they don't use, and that's kind of why it's smaller than CanvasKit, which kind of has the full API. But the problem is that like in order to do anything, you need like most of the surface area of Skia. So like even though they like trimmed out a lot, they didn't like trim out everything. They just don't expose any of the APIs anymore, and all the binary stuff is like still there. So so here's meshes kind of being animated by Flocker.
It's really funny. When I started doing the 3D stuff with Flutter, I actually went down the route of just doing it in Dart with Web GPU, because Dart had the Web GPU package. But this is before package web, right? This is way early days, right? And I was doing all this fun stuff, and I was like, okay, there's Flutter GPUs coming out. I'm not going to bother doing it. And it's taken forever to kind of get to where we are now.
Well, yeah.
Not saying that it hasn't been good effort and everything else. There's no criticism there.
Yeah.
But I'm just saying that it just means that I kind of like iterated all that. Just went, okay, I'm not going to do any of that till until
Well,
something else
they're
is stable.
they're like with Impeller and WebGPU, they're doing like really hard things that do take like years and years and years and years to mature. And like, like I've always wondered like why? Because WebGPU is like had started that process like what 15 years ago. Like it's been maturing for a really, really, really long time. And so, when you go try to basically like rebuild all these things that kind of like solve the same problems, but it's like the whole point of these, like say Flutter GPU and Impeller existing is like, well, we want to solve less of the problem. And like, because we solve less of the problem, the binary is going to be super small. And, like if your scenario only requires the problem to be solved less, that can actually be like really nice from a bundle size. But the problem is like WebGPU is big and Skia is big because people need those things. And so like the challenge is you have to be like 100% aligned on like what those things actually are. And if everyone was 100% aligned on what those things are, like WebGPU and Skia wouldn't be so big. But like
this is I think this is a point that Simon and I made to Ian back in like 2019, which was here's a framework or a UI toolkit that says we are against the lowest common denominator. And we would say to him, listen, all these behaviors that we aren't including, it's not like they exist for fun or as a joke. They exist because people out there needed them to ship their apps. And so instead of thinking it's okay to cut that out to save some bundle size, Flutter needs to go down a route where, if nothing else, find a way to tree shake that stuff out. Or Simon and I talked about, put up a website where you go and say, I want the small or the medium or the large version of Flutter, have some pre-packaged groupings so that you can build Photoshop with Flutter instead of just building the next stopwatch app, as I once famously did a UI challenge for that. It's like, but you can't just be like, no, you never get glyphs. Like that's not an acceptable approach to what the stated purpose of Flutter really is.
And when we were fiddling around with that, like what we had to do was absolutely crazy.
Oh yeah.
And we still couldn't get the performance we wanted because we're just not working at the level that we want to work at, right? And it ends up being a case of we might as well not bother using Flutter.
It's incredibly silly that the API doesn't exist because they're not even saving bundle size. They're not. They're just not giving you the freaking API.
I was really curious. I swear I seen like a like path, like something that gets the path, but then I'm like, no, I don't think it is there. Maybe I'm thinking about a completely different API.
Like any kind of detailed information, despite the fact it's there. Because they refuse to add an API. They are saving 0 bundle size. So it's not like something like the argument against, say, dynamic shader compilation is like people are super scared of it because of like the old Skia problems. And the shader compiler is big. And so those two things mean like Impeller's not going to get it. But like with specifically like text information, the renderer needs it or it can't freaking work.
I think there's something else that we're missing, and like so when I just want to phrase that because this came up recently as well, especially with app development. So there's a thing that's always existed in terms of software, which is dynamic libraries, right? This notion that you have binary application data that is loaded at runtime, that is picked and chosen by the application to load at runtime, right? Why suddenly everything flipped on its head now to this monolith approach where build everything into your product, right? Statically compile essentially everything in together. So obviously the idea of Dart and like tree shake it all in terms of the Dartland, that works. But when it comes to native stuff, that's not going to work. That's not going to cut it, right?
Well, sort of. I mean, so in Flocker, I'm solving a lot of these problems because like I know it's a freaking issue because like it's been this excuse for why we can't have nice things in Flutter for so many years.
But this is exactly where DLLs came in, right? So like
exactly.
Libraries and everything solved this problem. And I always thought like, oh, well, if you want to have this let's say you want to have video or audio or this or that, you could break things up into those components and then ship those components, right? And you're optionally, if you're talking about size, optionally include the bits that you want. I mean,
to some degree, Pub is doing that, right? Like when you get a package off Pub, it brings in video, and it does it in a way with FFI. So like
well, this is the thing, right? But what I'm trying to say is this is more about about the underlying engine, right?
Oh yeah,
that's the fundamental. That's the bit I'm sorry. That's the best, yeah. But when it comes, I mean, again, like there is this it's just like app development as well, like mobile app development, like the. Do you know that when Play Store first came out, this is maybe a little unknown fact for those people that weren't around at the very beginning. It actually has this mechanism that you could put in your manifest file to say, so this bundle is a library. You can publish to the Play Store as a library for other apps to consume. They had this notion of having this idea of a DLL, should we say, or a dynamic library at the very beginning. And there was this notion that they would publish updates, publish components of the platform as these like libraries in the Play Store, and then your apps could use them. So it'd be more of what we see now in terms of like Mac, Linux, and so on, where they have libraries that you dynamic libraries that you download and include as part of your app bundle, the installation of your app. So if you already got them, you don't have to download them, you don't have to install them, you don't have to use up that space. Now it's like, why don't we have like a lib Chrome or something, instead of every app that wants to use Chrome as their rendering engine, bundle in the entire running runtime of Chrome? Why are they not all sharing out the same right?
They have it. It's called Skia.
Right. But I'm saying like these apps are trying to take advantage of like HTML, CSS, and all the rest of it. But I appreciate what you're saying. But then to my point, like we I don't know what's happened with development, that we kind of reversed the boat in the wrong direction at the moment.
Well, I mean, there's like real problems when like if some like back in the Windows day, right? Like it was the opposite, and you had an opposite set of problems that like everything was always broken, because like everyone knows you like try to go like, even with Semver, you try to go like one version that's supposed to be compatible.
So that whole problem has actually been solved for a very long time, not just on Windows but on Linux as well, with like the side-by-side library support.
Yeah.
I think there's a lot of, it's kind of interesting that they put versioning into it, right? So it wasn't just like the name of the file, it became like a versioning support. But the interesting thing that operating systems do under the hood is this idea of file mapping into memory and copy on write to this sort of memory approaches. But what's really important about that with the DLL side of things, I keep saying DLL because I'm Windows based, but dynamic libraries. But the idea of this is that all that data for that your app would have to use from the libraries that you're using resides on disk, and only when you call a function and so on, it'll page in the portions of memory it needs. The problem that we actually have now is that because every app has a copy of all of this data, you actually have the same data, the same code loaded multiple times in memory. And you go, why is all my memory used? Because every app has got a copy of all. Previously, it would be optimized by the operating system as saying, oh, this exists once, so we don't actually have to put it into RAM multiple times. It knows that, oh, this library is being used by 10 apps and only puts it into memory once.
So did you ever do .NET? Because like they spent a ton of time on this problem. And so .NET had the GAC, it had like the global assembly cache, right? And the whole idea was this, that like you take the DLL and you would install it in the GAC, and then like things would reference like that exact like strong, they call it like strong name version of the DLL, right? Like now I thought it was an amazing idea because it does this, right? Like you get like one copy of the DLL and it's like stored in your machine. But for some reason, the GAC always like confused like most .NET developers because it was like too much complexity, and people just ended up saying, well, it's easier to just copy the DLL without naming.
Yeah, I think the problem here is that it's the level that was running at, and I think again it's a level that .NET runs at that higher was at the time running at that kind of like higher level. The fact that the operating system manages it all for you blindly, that you don't even have to care about it, is the benefit of stuff like that. That it's what we expect to have. The operating system is meant to optimize the running of all your software and run your machine really well. And when every bit of software goes against the operating system's best practices, effectively, it's like, this is nuts. This is nuts.
Yeah.
Anyway, but we're off topic completely there. Is there any questions coming in, Randall?
No, we're pretty much
No,
done
we
with
just-
questions. I keep prompting
I
for
mean-
more, but no.
I mean, look, if anyone wants to us to chat about a particular topic, feel free to dump it in the chat. We've got a few more minutes left of the show until the end of the hour. Feel free, Jesse, you don't have to stick around if you don't want to. I'm not saying you have to go. I'm just saying like, don't feel you have to stay to the end of the show. That's what I'm saying.
You must leave now.
When did we
Your
we
time.
last when did we last we met at FlutterCon USA last year, didn't we, Jesse?
Yep.
Yeah, I think it was the first time. Yeah. It'd be really. It's one of those things that I really like it if a bunch of us could get together and work on a project. It's just everyone's so busy, right? And finding the right project for everyone to work on. So I'd love to be helping out. Don't
So
have the time.
I missed some stuff, so I don't know the context for that. But to point out, I mean, Jesse's creating Flocker. I'm going to, as soon as he lets me, I'm going to use that to create a custom shader editor using Flutter, so you can see it live. Also, eventually, I'm gonna try to use AI to bring back Flock. And so, Jesse, I think we can have two directions on our website: Flock to stay compatible, Flocker to get all the amazing capabilities you're bringing in. So I'd say why don't we just see if we can build off each other a little, so our schedules don't have to match up exactly. And we know they never do. We've all got multiple jobs we've got to do. But I would say, hopefully, next year, can we all get to FlutterCon together? Can we at least have that be our crossover, the four of us plus some others?
And Simon can create Flocker.
Flocker, right?
No, Simon, you got to create Flockist.
Well, are you guys going to come to FlockerCon?
We'll have like a
FlockerCon. That's kind of like a country.
FlutterCon this year was at the Orange County Convention Center, which, as you walk through it, it's like way bigger than most airports. So we could just have like a section beside FlutterCon.
I was so gutted I couldn't make it this year. I was so gutted. That's the first FlutterCon I couldn't make.
Yeah, I was surprised. I was surprised you weren't there to help out with the AV and everything else like you did a year ago.
Yeah, it's just other things. Life happened, and that's
Yeah, I couldn't be there either. I was sad, but that's just the way things go.
Well, get the plans ready for next year now. I think
we
we already have
question.
dates.
We have one more
something
question.
I actually really want to be doing, and I actually want to run this past since Jesse and Matt are on the screen at the same time here. We'll look at that in a second. So something I wanted to do for a while is I've been looking at, I've done a lot of hardware-based electronics and other things, that side of development as well, the hardware side. And I've been putting together plans for a digital conference badge, right? So the general idea here being that it's an interactive conference badge. You've got NFC, you can like tap it at someone else's, it records your contact information or whatever, however you want to do that. Tons of ways you can do things, but to give that kind of the conference scene a bit more of an uplift than like every conference printing their own badge, the idea being that I've got is that when you book your tickets, you can add in the addition of a digital badge for like X amount of money, right? But that's yours, right? Now, the next conference you go to, you can load it up with a package from that conference so that it has all the graphics and everything else for that conference. So you only have to buy it once. You don't have to buy it for every conference you go to. But the idea being that every conference can use it as their system for badges, right? And one of the things I was doing with this idea was I wanted to run Flutter as the rendering engine. Now, price point for something like this is you need to be super duper cheap, right? Like you need to bring that cost of hardware all the way down. So anything you can do to relieve that cost, and a big portion of that actually goes to a lot of the CPU memory and that side that you actually need to run something of, like you could do something cheap, right? It's a dime a dozen to grab anything that's Arduino compatible and to like put together some simple sort of display and throw that together. But it won't run Flutter, right? If you want to run something like Flutter, you need to be running Linux. At least an embedded version of Linux, you need to be running quite a larger stack, a software stack. Anyway, so I was working towards that approach. I parked it for a while. I've got all the stuff still, but what kind of let me down is the fact that we really need to go down the risk approach, risk V, and for a CPU. And at the time, Dart and Flutter weren't supported. Now, Dart supports the RISC-V architecture. Still, Flutter does not support that out of the box, right?
I'm sure
So
we can
that
do it. We're doing it.
So that is what I was going to say. That would be, to me, that would be the thing that actually makes it worthwhile. Because if you can get these embedded chips running the Flutter stack, essentially, like it's the advantage of being able to run that Dart code on top of a rendering engine that makes it really viable. So suddenly you can do all these fancy animations and everything on badges. Now here's the next thing. You can imagine from a digital side of things. So you got sponsors. Those sponsored logos can be coming up in a proportion of like the badge, and suddenly this becomes an actual viable proposition for a conference to use. It really becomes a very powerful asset for every conference. So there's definitely a product here.
I mean, the cool thing about the way Flocker works is so the embedder's Rust. So like Rust works almost all the places, right? Like, and the embedder actually doesn't even require you to run Flutter apps. So like I've posted demos of it running like Rust apps, like Bevy, Game Engine, and things like that. The embedder just exposes system services like GPU access, media access. And then because it's just running WASM apps, well, WASM works pretty much everywhere. And I believe the WASM bytecode is a bit more compatible with RISC anyway. And so it's like all you need is basically a WASM runtime and Rust, and everything works. So that makes it really easy. Like, let's say like someone wanted to use it on a new platform. Well, with the approach the Flutter team's been taking, it's like every platform is like such a pain in the butt to maintain that they had to stop maintaining platforms. But with this approach, it's super easy. Let's say, well, okay, we want to get it working on a Raspberry Pi. Okay, let's go do it. Like let's just compile that Rust and figure out, well, what's the GPU story here.
Just try out. There was a question. Well, I didn't say question, but Sharif.
Yeah,
it was Nitro Web GPU blockers.
So Sharif's been porting all the Nitro React packages over to Flutter, and Nitro Web GPU is his wrapper and Web GPU.
Yeah, so that like it's awesome. Like I've seen some kind of videos of Nitro, and conceptually a little bit different, right? Like, so Nitro is giving you Web GPU access kind of as a Flutter package over FFI. And so that is great, but it doesn't say allow you to make Flutter itself use Nitro to render because it's living outside the engine, right? And so it like awesome approach if you're using an existing Flutter app and then you like want to embed some like Web GPU stuff in your app. It could be a great approach to take, but it won't make Flutter itself use Web GPU, which is where I'm kind of coming a little bit lower level and saying, well, like basically the embedder's job should just be to expose Web GPU to the guest, and then like whatever framework happens to use Web GPU, whether that's a custom port of Flutter like I have, or practically everything supports Web GPU because Web GPU is the thing you need to support if you ever want to run in the browser. So like I posted demos of like GPUI, which is what the Z editor uses, running inside the Flocker embedder. So
Jesse,
it's interesting.
A question on terminology real quick. So you've described this Rust embedder which consumes WASM. So in what actual technical sense do you have, is this a fork of Flutter? Because it actually kind of sounds like maybe not Flutter at all.
Dart is component to WASM.
Yeah,
well,
so
but everything can compile to WASM, right? So is this a
Sure.
WASM embedder that exposes system services, or is this in some way actually a fork of Flutter in some meaningful sense?
Yeah, I mean, there's a lot of forks of a lot of things, including Flutter to make Flocker, right? So the Flocker embedder started as a Rust port of the Flutter embedder. Now it started there. It's very, very different now because like as I got into it, I realized that like there's a lot of things the embedder gets wrong. And if you don't solve those problems, you can't like provide proper media services and things. But like definitely the whole idea I had with embedder was like Flutter is at least my opinion, Flutter is the best cross-platform framework in the world. It solved the problems better than everyone else. And so and then embedder is central to how those problems are solved. So I thought, well, start with the embedder. And so I kind of ported that. Now, when it comes to Flutter itself, yeah, like anything can compile to WASM. But in order to make this work, I did have to fork Dart, because Dart itself, when it comes to WASM, even though it has a standalone, there are some, like Dart compiles legacy like support for things like GC because they want to support like older browsers. Those things are now deprecated. And so like modern WASM runtimes won't even run the Dart that the Dart compiler generates because the Dart compiler generates code that's like years out of date. So like I did have to fork the Dart compiler to make the Dart compiler generate modern WASM. I did have to fork Flutter because I ported the Canvas kit rendering engine to work on top of Skia Graphite exposed by Flocker's GPU. The thing I haven't touched at all is the Flutter framework. So I forked, made a new embedder based off the current embedder. So that's not really a fork, more of a rewrite. I did, use the Canvas kit engine as the reference for the port. But Flutter framework is totally unmodified. 100% of the things that the Flutter framework are doing are just they're there, and it's the normal Flutter packages. So,
and what ties your so I mean, on the one hand, if it's just like, oh well, the framework is unchanged because the framework is Dart and Dart compiles to WASM, and therefore the framework doesn't have to change. That kind of means, oh well, you can use all of Flutter, but not necessarily that there's anything in your embedder related to Flutter. But does your embedder continue to maintain, let's say, like the engine layer API, the place where the framework actually does cross into the engine? Do you still have that? Is that what makes it a Flutter fork?
Yeah. So like the engine's totally replaced, but like the engine never freaking changes. They're too busy trying to change impeller. They're afraid to change that API. So like that's not actually that big of a deal. Like the cool thing, like this wouldn't have been possible in a reasonable amount of time if something like the Canvas kit renderer didn't already exist. Like my point has always been that like Flutter's like 90% right. It's just that, it's that last 10% where it kind of falls apart, right? Like Canvas kit exists, but they don't use that renderer on mobile. They don't use that renderer anywhere. They're maintaining all these different engines, right? So I just took what the Flutter team did, like amazing work with the Canvas kit renderer, and then they abandoned it. Like they don't maintain it anymore. They're working on SK WASM, which in my mind is actually the wrong thing, because the whole reason SK WASM exists is because they're trying to get rid of Skia on web now too. And I've always been obviously opposed to that. I think Skia is amazing and great, and there's no reason to reinvent the wheel there. So if you kind of take this approach and say, like, instead of like throwing out all these things, we're just going to use them. And I don't care if the bundle's bigger. I can find other ways to solve that problem. You can really accelerate because you're leveraging things shipped from a much bigger team.
I do remember the Flutter team / Dart team when they were working on web, and they started using all the inbuilt. There was Canvas. I think it was Canvas kit. They started using some of the inbuilt, essentially the Skia runtime is built into Chrome and the browser and so on to accomplish. So they don't have to ship Skia as part of your app. But then it was like, oh, they're running into bottlenecks where these features weren't there that they wanted to use. And then now you've got this kind of, you have to, it only works on certain versions of the browser, this, that, and the other. With web, compatibility is a massive thing, right? That you need to have wireless compatibility. So I think that's where that kind of idea of SK WASM came in, where it's like, okay, let's just essentially ship like Skia as part of your product.
No, like, so with Canvas, so we're now on like the third Flutter renderer. On
I know.
With
the first one was DOM.
Yeah, so it started with the web renderer, which is like, I don't even know, that predates me, right? Like,
it's DOM. Yeah, it's using the browser to
well, it was using like the Canvas API in the browser, I think, right?
It was DOM and Canvas and a mixture of it all together to kind of try and achieve the end result. But yeah, we go.
Yeah, so then when the Canvas renderer came around, like WASM's actually like good enough to run Skia in the browser. And so, because like historically Flutter had already been using Skia, it made like a lot of sense, and they could get like pixel perfect rendering in the browser just by shipping WASM Skia, right? Like, and but SK WASM is basically now. So the problem with Canvas Kit, like everyone's complaint about like Flutter Web is always like, well, like there's this big initial payload, and there's that big initial payload because like Canvas Kit is the full freaking Skia. And like, if there's any platform where the payload actually matters, it's definitely web, because the other platforms, it's on your disk, right? Like, and so with SK WASM, what they wanted to do was like, let's just like, they take.
I've got the two names mixed around. Yeah.
Yeah, they take the same Skia code, but then they make their own like C++ wrapper around it. That way they can tree shake out the stuff that's not being used, and you get like a smaller WASM file that like contains only the wrapper plus the things the wrapper references, and then the size of the bundle drops from, you know, like I think the full Canvas Kit is like 7 megs, and then like SK WASM is like what, like 3-4, and then it like compresses really well, so it's like 1 meg compressed. And so like SK WASM started as this, like, how do we like optimize the WASM bundle so we don't, like, we can get that payload down. But they are actively working on now turning SK WASM into like an impeller version on web, so that, you know, eventually they have the same rendering engine everywhere, right? Like, and so if you kind of pay attention to the commits in SK WASM, that's what they're moving towards right now.
If it's kind of interesting if you actually look at how many since at least since the last couple of years, more so this past recent year, the amount of rendering engine projects essentially around, like especially with Rust and everything else, the amount of like this kind of solving this space, it's been done so many times over now, and by many different people, and there's definitely the marketplace for like a framework like Flutter to actually do like the rendering side of things, that has actually heated up quite a lot. And you know, the way that Flutter works in this UI system and the framework itself, that's not going to change. That's self, that's good, that's and so on. As you were saying, it's what goes on under the hood. And I think that it's kind of interesting that the fact is that there's so many different ways of doing that rendering now. And
the interesting thing, like, I think it's a testament to like the original kind of Flutter godfathers, a lot of these projects in other languages that have kind of like arisen and gotten really popular, whether it's, you know, like Compose, or whether it's something like React Native Skia, like you talk to the people that built these things, they'll all say that they looked at Flutter for how to do it, and they used the way Flutter works as an inspiration, because like the reality is, while I may like nitpick certain things I don't like about decisions they made, the architecture is awesome, and it is the best, like most mature, fully built out across all the platforms that Flutter supports. There is nothing like it. Like Compose is not there. You know, like there are things that are trying to copy it and like be as good, but Flutter is still kind of the gold standard when it comes to this type of, you know, I want pixel perfect, I want like the same exact app running on every platform. No one does it better.
The best years of Flutter were 2017 to 2019. That's my opinion. Jesse, again, to help people understand how they might use Flocker, as one example, like let's say we talked a lot about glyph bounds, glyph paths. Let's say someone's writing their Flutter code, their Dart code. Obviously, we have like text painter, which is about as close as you get to that stuff currently. What would it look like in Dart, and how would you put this together for someone to write Dart Flutter code that can now use your capabilities to access glyph bounds?
Well, the cool thing is, like, if you wanted to try it right now, even without Flocker, just go get Flutter 0, because Flocker is using Flutter 0. Flutter 0 has Skia Dart as a supported thing. And so Skia Dart already exposes a lot of those APIs. So like today, even if you were using mainline Flutter and then you wanted to use Skia, you can just go get Skia Dart and you get direct access to all those APIs and you can use them in your app. The primary difference between, say, like Flocker and doing that in Skia Dart is Flocker's engine builds on top of Skia Dart. So you don't get like both the Flutter engine plus a separate extra copy of Skia that's provided as like a third-party package and not like fully integrated in.
So Flocker, if one were to use Flocker, then included in that distribution is going to be some kind of provided package SK Dart. It's going to import package SK Dart provided by Flocker, and then you call the APIs.
Yeah, I mean, right now it's just a normal package. So like the idea behind Flutter 0 was like, what if you like everything was just a real package instead of saying like, well, this thing's like part of the engine, so it's not like, it's kind of like jammed in there through some like weird way, so you know, like it's there and you can't get rid of it. Well, with Flutter 0 you can go like install all of these things, and I think his goal was eventually like to make like Flutter just a package too. But with Flocker, that's the way it's working. It's just the normal Skia Dart package. Of course, I do have a fork of it because it like integrates with Flocker more directly, since Flocker is exposing web GPU via a device. But in terms of like what would the code look like, the code would look pretty much identical to what it would look like if you were using the Skia Dart package. You just call Skia.
Yeah, and for people listening, Flutter 0 is it fair to call that a Flutter fork? Is that an appropriate
Definitely.
label for it? So Flutter 0 is a Flutter fork created by Mate Knopp. So maybe Simon, you want to go invite him onto the show sometime and see if he's interested, but then he can explain the basis upon which Flocker is built, and then we can all begin to understand this ecosystem that is emerging.
Yeah, like this is, if it wasn't for what he did with Flutter 0, I probably wouldn't have even tried to do Flocker, because like me and Matt know, you like when we went to do Flock, like a lot of like the stuff we had to deal with was just like, it was tooling. We wanted to like work on the actual like engine and core.
Oh,
so much to do with the freaking CLI that like we spent all of our time solving like the problems we didn't want to solve. And so like he did an amazing job on that.
You like build systems, right? You have to like build systems, so like building Flutter engine.
Oh yeah, like even like I've ran it out this before. Like you can't just like build Flutter yourself because they use all this proprietary like build infrastructure.
And that's one major problem. And obviously, Jesse, you went off and spent a lot of time on that. But there's even all these little hurdles along the way. For example, like if you look into how Flutter test runs, how Flutter test bootstraps a test, there is hard-coded code. There are strings of Dart code in the Flutter CLI, which are then turned into, like hydrated into code that's then run so that Flutter test can execute. And there seems to be like no way around that. And you also get into areas of the CLI where you're going to have some if statements or switch statements that, well, no, I don't want either of those if conditions. We're in a third situation. So you have to go fork the CLI to add your else if in the middle of that, just so you can then escape into what you're trying to do. So both in the CLI and the build system, there's plenty of little annoyances to get in the way.
Yeah, so Flutter 0, I think, is like, it's enabling a lot of things. So like, obviously I'm doing Flocker. There's been a lot of people experimenting with Flutter 0 directly. And I know there's now also in the works Dart native, which I don't think it's launched yet, but Joseph would be a great guy to bring on too. He could talk about what he's doing with Dart native and like how he's taken Flutter 0 to make something it's like that's very, very, very different from the way normal Flutter works, and only possible because you know, all the work that was done on Flutter 0.
Cool.
All right. Well, Simon, how long does this thing usually go? I see we're plus 2 hours.
We're at the mark now.
We're at one of the marks that we often hit, but we do have later marks that we've hit many times too.
I think we'll call it here.
Yeah,
Super
that's
interesting. Obviously, friends of the show, welcome on any time. We should find some nice topics to talk about. You can definitely come back and talk about Flocker and Sharp Flocker. So
Great.
And don't forget to check out renderobjects.com for those who joined us in the middle of the Flocker talk and don't remember why we actually started this thing. Renderobjects.com.
Yeah, go get a pitch. Go get a picture there. Yeah, definitely. Links out there. There you go. Renderobjects.com.
Hey, it does show up in chat. You can put URLs.
Yeah,
in
we
there.
can. We can. They can't.
Okay.
We can. Anybody in blue can paste links, but not anybody that's not in blue. Makes sense.
All right. Well, thank you for coming, and
Thanks for having me.
What did I forget?
Tomorrow, Flutter Observable.
Oh.
I'm going to be on talking about block signal, my new ecosystem that I hope would help solve a lot of problems at once. It's the rigor of block with the flex and the speed of signals. Just enough block, just enough signals on both sides. Anyway, I'll be talking about that tomorrow. I have the URL.
All right.
Wait, URL.
Pop it in the chat.
I pasted it already. It was earlier. I think this is it.
Right.
Oh,
there you guys in the chat. Thanks everyone for joining us, and we'll see you same time, same place next week. Bye.
Thanks everybody. See you later.
bye.